Okay, so let's talk about this one. Now here they say a closed rectangular box has to be constructed as follows. Now these are the dimensions. So here they say allow the length to be L, the width to be W, and the height to be H. Remember that the width is the same as the breadth. And this is what they say. The length of the base has to be 3 times its width, and the volume has to be 5 meter cubed. The material for the top and the bottom parts costs 15 rands per square meter, and the material for the sides costs 6 rands per square meter. And here they say, please show that the cost to construct this box can be given by the formula 90W squared plus 48W times H. And this is for 4 marks. And after you have successfully done that, then they say, determine the width of the box such that the cost to build this box is a minimum. Well, it's a very good question. So let's give it a good look. Well, if they say to you something is a box, then you know that it's a rectangular prism. They didn't need to tell you that it's a rectangular prism. So don't assume it's a cube. No, if they say a box in general, then it's a rectangular prism. But if they said to you a cube, that's when you'll say all the sides are equal. Right. Now, of course, we need to make a diagram so that we can visualize how this rectangular prism looks like. And I was actually taught to do this diagram, I think it was back in grade 5, by, we used to call her Teacher Mpo, so it's Mem Swazi. She was a very good lady. Now, this is what we will say, guys, more or less. It's a rectangular prism. Now, when they say to you it's a closed rectangular prism, what they're saying is the top surface is present as well. But when they say it's an open box, then it means this area is missing. Of course, it's going to affect the surface area formula if the top was missing. Now, I also want you to realize that they said to you the material for the top and the bottom surfaces is 15 rands per square meters. And they came back and made a general statement. They said the material for the sides is 6 rands per square meter. And listen, they said the sides. Under normal circumstances, we know that these are the sides. And then this surface as well as, what can I say? Yeah, this blue surface as well as this pink surface, the front and the back. We know them as the front and the back, right? But in this case, we are going to know them as the sides as well. So anything that is not the top or the bottom is a side in this instance. Thank you so much for understanding that. So let's get down to business. Well, here they said to us, the length of the base is 3 times the width. So in other words, the length is 3 times the width. So meaning we can actually express the length in terms of the width. So meaning every time we see the length, we can choose to say 3 times the width. And of course, this is going to be the width. And this one as well is the width, and that is the width. This is the length, of course, we know. And this is also the length. This is the length. But this one is the height, right? So we need to respect the height and call it h. Okay, fine. So now here I want you to realize that the cost has to be a function of the width. In other words, our cost function has to be cost in terms of W. So that's what I want you to realize. But before we can go there, we need to use this information they gave us with regards to the areas. Now, this is the area of the top and bottom surfaces. I don't know what you'll say. Maybe you'll say, let AT and B be the area of the top and bottom surfaces. Yeah, maybe you'll say that because you need to tell them what you are doing, all right? Don't just say AT and B there. So what is the area of the top and the bottom surfaces? Well, remember, we have two surfaces, so you can simply say 2 times the area of one surface, okay? Well, the top is just going to be the length times the breadth. So your length is going to be 3W and your breadth is going to be W. So it means the area of the top and bottom surfaces is just going to be 6W squared. Okay, fine. So now we need to come and find the cost for the top and bottom surfaces. But you need to know your units. The units are terribly important because the units are going to make sense to everything. So what do I mean? Well, the area is measured in meter squared. It's terribly important that you say that. So now that we know the area of the top and bottom surfaces, then how do we find the cost? Well, what they did here is to give us the cost as a rate. Remember, guys, I'm a tutor, and for high school learners, one-on-one sessions, I charge 120 per hour. What is the meaning of 120 per hour? It means in 1 hour, I'm going to charge you 120 rands. So that's exactly how they gave you the cost. Okay, this is how they said it. So we said the top and bottom parts, they cost 15 rands per meter squared. In other words, 1 meter squared is going to cost 15 rands. Do you get it? But now we want to know what is the cost of the top and bottom surfaces. So we have to come and say, well, how much will 6W squared M squared cost? Well, for this one, you'll say this one divided by that one so that the meter squares will cancel out. And then you say multiplied by 15. So 15 by 6, you get 90. So now we can conclude and say, therefore, the cost of the top and bottom surfaces is just going to give us what? 90 rands. Awesome. Well, is it really 90 rands? Yeah, it's 90 rands, but we have to say W squared. Sorry, I forgot that. But then the meter squares are going to cancel when you say this one divided by that multiplied by that. Okay, fine. So now we need to go to the sides. So we want to find the area of the sides. And even though they generalized and said it's sides, but we need to be specific. when finding their area because they are not all the same. So when it comes to the sides, we need to consider the front and the back parts. And since the front and the back have exactly the same area, then we can say 2 times the area of one surface. Okay? Now the area of the front is just going to be the length multiplied by the height. Then we say plus, we go to the actual sides, the literal sides, not lateral. Like they're literally sides. That's what I want to say. So when we look at one side, because we understand there's 2 of them, all right? But if we consider one, then the area of one side is the width times the height. So this is what we say. So this means the area for the sides will be 2 times 3, which is 6. And 6 plus 2 is 8. So this is the area for the sides. Now that we know the area for the sides, then what are we going to say? Well, it's very easy. We come and remember that, oh, they said to us, 1 meter squared of the sides costs 6 rands. So now we want to know, oh, it's the area. I forgot the meter squared. Please forgive me. But please make sure you don't forget the meter squared because it's going to put meaning into what you're doing. So now we want to know how much will 8 meter squared cost? So, well, here we take this one and divide it by that and multiply it by that one. So when you say 8 by 6, you simply get 48 WH. And that is the cost of the sides. So now we know the cost for the top and bottom surfaces. We also know the cost for the sides. So now we can find the total cost. And this is how we find the total cost. Well, we say it's the cost of the top and bottom surfaces, which we found to be 90 W squared. And then we add this to the cost of the sides. And after we have successfully done this, it means we have acquired our first 4 marks. So that's how we're supposed to approach. Now, the last question is for 6 marks, and it says to us, please determine the width of the box such that the cost to build this box is a minimum. So here we need to minimize this cost. But if they say to you, find the width, then it tells you that your cost function has to be a function of the width. It has to be expressed completely in terms of the width. And in this case, we can see that it's not expressed completely in terms of the width. Why? It's because if we look at the second part, we can see that it's actually, well, we actually have, in fact, H inside. So we need to make sure that everything is completely in terms of W. So the question is, how can we make sure of that? How can we eliminate the H that we have here? Well, we need to remember what they told us, right? Because we need to express H in terms of W. And this is what they told us. If we look at the third bullet, they said to us, the volume of this box has to be 5 cubic meters. So that's what we are going to use. And we know that the volume of any figure, any three-dimensional figure, is the area of base, which is 3w squared, multiplied by the height. But now we know that the volume has to be 5. So 5 is equal to 3w squared times the height, which means that the height as the subject of the formula will be 5 divided by 3w squared. And guys, please don't use this sign because you're still young to be using that. So please stick to the normal steps. So now that we have expressed our height in terms of the width, then it means we can now express the cost in terms of the width. So we say, okay, fine, our cost function is now going to be 90w squared plus 48w into 5 over 3 w squared. And how can we simplify this? Well, here we can see that this w will cancel one of the w's in the denominator. And we say 48 times 5 over 3. Well, it gives us a solid 80. So it means our cost as a function of the width is just going to be 80 over the width. But of course, since we know that we have to differentiate the function, then we know that according to the rules of differentiation, we are not supposed to have a variable in the denominator. So we need to write 80 over w in negative exponential form. And this is what we get. Then from this point, we differentiate our cost function. So using the power rule, derivative of this one is 180w, and derivative of this one is negative 80 w to the negative 2, right? But then, of course, we need to equate the derivative to 0 because we know that the minimum cost is actually implying the minimum, what can I say? The local minimum. Yes, that's what I wanted to say. And for the purpose of solving for W, well, I'm just going to write this in positive exponential form. So this is how it's going to look like. And then here we can easily multiply throughout by the LCD, which is W squared. So we have 0 equals 180 W cubed minus 80. So if we take this 80 to the left-hand side, it becomes positive, and we divide throughout by 180. So we actually have 80 over 180. But of course, if you go to your calculator and say 80 over 180, in its simplest form, it gives you 4 over 9. And now you just need to find the cube root on both sides. Then you find that your width has to be the cube root of 4 over 9. But since we can simplify this using the laws of exponents, then it means the best we can do is to use the calculator. So let's see what is the cube root of 4 over 3. Well, we are simply going to get 0.76 meters. So that is the width of this rectangular prism. They're only looking for the width, so we don't need to find the length. We also don't need to find the height. But if we had to find the height, then we substitute the width there. If we had to find the length, we multiply this thing by 3, and we should be happy.